You're welcome back. In the last video, or perhaps let me say in tutorial question 1, we talked about discontinuity of a function and we explained the concept of removable discontinuity. So in this tutorial question 2, we want to look at another type of discontinuity, and the type we want to consider here is called jump. Oh, do you like that? It is called jump discontinuity. So what is it all about? Let's consider this question now. We are given our f of x to be this. And the question is this: we are to determine if the function f of x is continuous at x equals to 4. And if not, we should explain the type of discontinuity. So let's proceed. So if we are to find the function at x equals to 4, which one are we to use? Are we supposed to use 2x plus 1, or we should use 10, or we should use x squared? Definitely you will agree with me that we are to use the second one, because based on that, what we can refer to as the piecewise divine function, which I mentioned to you during my lecture on function of real variables, you will notice that the function is indeed 10 when x is equals to 4. So that is very simple. So the next thing we want to consider now is that what is the nature of the function when x is approaching 4 from the negative axis? What do I mean by that? If we proceed from when x is equals to 0, what is the nature of the function? When x is equals to 1, what is the nature of the function? When x equals to 2, what is the nature of the function? When x is equals to 3, what is the nature of the function? So when x equals to 3.5, 3.6, 3.7, 3.8, 3.9, 3.999, 3.99999, as s is moving closer to 4 from the negative axis, what is the nature of this function? So of course we're going to use the concept of limit. But the point is this: which one are we supposed to pick? Are we supposed to pick 2x plus 1 or x squared? I'm talking about the range of x, or perhaps I can say as s move closer to 4 from the negative axis. And even if you look at the piecewise divine function, you notice that if x is less than 4, we are to use the first one. We are to use the first one. Look at it very well. 2x plus 1. That is if x is less than 4. And that is the range that we are going to use to evaluate the function, if we can call left-hand limit. But that left-hand limit is a little bit grammatical. Let's come down to our level. It simply means as x tends to 4 from the negative axis, what is the value? So we use the first one, 2x plus 1. And we can see here that it is what? It is 9. So the second thing now is called the right-hand limit. What do I mean by right-hand limit? Right-hand limit means that as s tends to 4 from the positive axis. This time around, I will have to focus on, let me start from 7. When x is 7, what is the nature of the function? When x is 6, what is the nature of the function? When x is 5, what is the nature of the function? So when x is 5.1, when x is 5.9, when x is 5.8, when x is 5.7, when x is 5.5, when x is 5.2. Okay? So as we are moving closer to 4 from the positive axis, which one should we pick? Definitely we are going to pick this last one, which is x squared. As you can see from the piecewise divine function that it is true when x is greater than 4. So based on this, we can now evaluate and see that it is 16. But there is a problem because the left-hand limit is different from the right-hand limit. So which means that the function does not exist. Or perhaps let me say that the limit does not exist. So we can say like that the limit of that function does not exist. What happened? Because there's something called jump discontinuity there. Exactly. So we can conclude that f of x is discontinuous at x equals to 4 due to a jump discontinuity. Thank you very much. Bye.